Hello, everyone. Today, I want to record a new method I've kind of developed to create LoHA uh, from a dataset, and it's fairly different from my previous method. So I thought I would share that so that you guys have a new method to try, and I think it's providing much better results than the usual method, and it's actually much simpler. So let's try to create a model. So to spare you some time, I've already kind of collected a whole bunch of data um, for this model. It was suggested by someone on Civit AI, so I said, why not take the opportunity to create this model and also to teach you guys how to do that. So I've collected 40 image of Kylie Jenner, uh, and I've kind of put them all into this one folder here that I've called 30 underscore Kelly space Jenner. And I'm not going to use any caption files in this case. I'm just going to rely on the folder name that I've given to this project to actually capture the actual or create the LoHA. And what I'm going to do first, as a first step, I've got a bunch of different image with different aspect ratio. And one other thing that is very important in this new method is to have perfectly sized buckets for each of the different aspect ratio that we're going to have in the data set. You need to have perfect buckets. And since here I've got 40 image, I'm very tempted to create buckets of 4 images each. So to do that, I've written a small tool that I've actually shared, and actually I've created a GUI for it. So I'm going to use the GUI version in this case. So I'm going to first of all copy the path to this data set, and I'm going to go into Goya GUI, and I'm going to go under Utilities, under Group Image, and here I'm going to use this new utility that allows you to create group of image of a given size. So I'm going to create a group of image, so a group of 4, so because I want to have each group of image to contain 4 image, and I want to output that into a folder that I'm going to call image underscore G4 for a group of 4. And what that's going to give me is perfectly sized image in group of 4 that will be of the same aspect ratio. And this is key to this method. You need to have perfectly sized groups because you're going to see what we're going to do next. So this also allows you to include subfolders. If you had more than one folder containing images in that source folder, you could just tick that in and it would actually include all of the images within those folder as well. And if you had caption files or whatnot, you could also select to not copy other files in that folder if there was. In my case, I don't have any other files, so it doesn't matter if I tick that or not. So I'm going to leave it untick. So now that I've got this, I should be ready to, I guess my GUI is a little bit wonky. It shouldn't be caption image, but it should be create groups, but that's fine. We know what we want to do. I'm going to update that later, but I'm going to click that. So now it's going to create those groups. And if we look in here, we should see in the actual GUI, where did I run the GUI? Oh, it's here. So it went, not that one, so that one, sorry, that's just the one when I run it manually, but if I want to run it through the GUI, it went and created all of those images. It processed the image and it created a whole bunch of groups of 4 images. So now if we look into that folder, we should be able to see under img underscore G4 that we are going to have perfect aspect ratio of groups of 4 of image. So if we look at them, for example, you're going to see that the first, second, third, fourth, they all have the same aspect ratio. The next batch will be slightly different aspect ratio. Again, it kind of changes slightly, and so on and so on. So we have now buckets of 4 images of the exact same size and aspect ratio. So this is the prep for the data set. That's it. I don't do anything else. I don't create any caption files, no nothing. I just keep it like that. As long as the name is perfectly fine, that's what you need. So now that we have that, we're ready to go and start to create or to actually set the training. So I'm going to go and copy the destination folder name. I don't really want to get that part. I just need to copy this, and I'm going to go into the Dreamboot LoHA GUI. I've already sort of loaded an existing training that has most of the settings I need, so it's going to be easier to just set things up. So I'm just going to go ahead and paste my image folder here. It's going to be the image underscore G4 for Kylie Jenner. And I'm going to copy this. So now I can put where do I want to save my config file when I want to save it. So I'm going to put that folder name there. Same thing for the log folder. I'm going to put the folder that contains the image in there. Now here, obviously I want to get that Kylie Jenner as the name for my model. I'm outputting my model into a licorice folder that I maintain separately, so that's going to be that. I'm going to put, again, the model name as my config file, so Kylie Jenner, and I'm going to throw in the comment for the training to be Kylie Jenner as the trigger words. So those 2 words will be the trigger for the model. So that's about it for the folders config. If we look at the source model, I just use like the V1, like Stable Diffusion V1.5 prune checkpoint as my base model for the training. And training parameters is where it's interesting. So let's walk through them. So we're going to create a licorice LoHA, very important. In my case, I'm going to have a train batch size of 4 images. And I'll want to train that for about 4 epochs. So I'm going to go for 4 epoch. And you'll notice that as part of this training set, I also want to have 30 repeats of those 40 images that I've got in the group. So I'm setting my repeats to be 30 through the folder name here. Next, save every n epochs 1, that's fine. Capture extension, it doesn't matter, I just put .txt, but since I don't have any captions, it's not going to read any caption file. It's going to default to the actual folder name for the caption. Mixed precision, I always do BF16 and save precision FP16. Depending on your card, you may be better off to use FP16 for the mixed precision. Depending on your card support for BF16, obviously. So number of CPU threads per core, I leave that to 2. C, I leave that to 1, 2, 3, 4. I could just not leave that. So cache latence, obviously, I don't want to actually have, or well, I want to cache the latents, and I want to cache the latents to disk so that on future run, if I ever run that training again, I wouldn't have to go and cache the latents. I would just read them from the cache file on disk. Learning rate, very important. I set that to 0001. I do a learning rate scheduler of cosine, learning rate warm-ups, 0. Optimizer, Atom W, that's the best choice. If you can run Atom W as your optimizer, go for that. And I forgot to mention that training batch size, depending on how much VRAM you've got, you may be stuck to 1. I can go much larger because I've got a 3090. But in this case, I'm going to stick with a batch of 4. Optimizer, extra arguments, nothing. So text encoder learning rate, the same as the learning rate, and the same for UNet. I set them all up to the same learning rate. I know in the past I was setting the text encoder learning rate to be half of the UNet, but because I don't really use caption file and I only use like 1 or 2 words as caption, I find that leaving the text encoder learning rate higher produce much better results. Next are the network rank and alpha size. So I set that to 32, 16, then the convolution rank dimension to 8, and the convolution alpha to 4. Max resolution, I leave that to 512 by 512. Step text, stop text encoder training, leave that to 0. Enable buckets, that's very important because we are going to want to use buckets for the different aspect ratio. Advanced configuration, leave that to off. Now, gradient accumulation steps. This is where you're going to go and look into the results. So see how I've got 10 groups. So I've got group 1, 2, 3, 4. So I've got essentially 10 different aspect ratio. So I've got groups of 1, and since I've got 4 image in my buckets, so those 4 image equals the training batch size of 4, and the gradient accumulation steps will then be 10 because I've got 10 groups within my data set. Weighted captions, I don't need to have that turned on. That's if you were to kind of weight some of your caption words. I don't, so I can leave that off. Prior loss weight to 1, that's fine. Learning rate number of cycles, learning rate power, just leave that empty. Additional parameters, leave that empty. Save every end step, I leave that to 0. Save last end step 0. Save, that's repeating, that's interesting. I guess I've got something to correct here, but okay, just notice that in the GUI there's something weird about that. So one of them is obviously wrong, but that's fine. Just leave them to 0. It doesn't matter. Keep end token 0, clip skip 1, max token length 75 because we only have like a few tokens. We don't need to go very high. Experimental FP16 training, just leave that off. Gradient checkpointing, leave that off. Shuffle captions, leave that off. Persistent data loader, off. Memory efficient attention, off. Use Xformers, on. Obviously, color augmentation, flip augmentation, leave them off. Minimum signal to noise ratio gamma, put that to 10. So that's going to give you, it helps to produce lower loss. So I put that to 10. Don't upscale bucket resolution. So if you had bucket image in your buckets that are smaller than 512 by 512, it would not upscale them. You can leave that to on. Bucket resolution steps, leave that to 1, so that we want to get the full size of the image to be used for the actual training. Random crop instead of center crop, we leave that to off. So you want to set the noise offset type to multi-res, and you're going to set the multi-res noise iterations to 8 and the multi-res noise discount to 0.2. Drop out captions every n epoch 0, rate of drop caption dropout 0, VAE batch size 0, and everything else pretty much is off. Resume. We don't train max train epoch and max number of worker for download, set that to 0. And if you had like an API key for 1B, if that's what you wanted to use, then you would put your key and turn on 1B logging here. And I'm not going to use sample image for the training. So that's about it. So for now, I think we're pretty much good to save this and then start the training. So let's get that training going. We can monitor that everything is going to look good here. So if we check, it should start to go through the different buckets. So now we have our 10 buckets, so buckets 0 to 9, and let that have 4 image each, and we're going to have like a total of 120, I guess, repeats through the 4 epochs on those, because 30 times 4 equals 120. So now it's literally caching all of those. It's actually already cached the image, and now it's starting the training. If we look back into that folder now, you're going to see that those .npz files are the cached latents for each of those images. So if we were to rerun the training again, it would just go and read off those files instead of reading or recalculating the latents for every single image every time. So for people that do like training with tens of thousands of image, this saves a lot of time. So while the training is actually running, if we look again at the data set, we're going to see that I've got different image, like close-ups, just like the shoulders, head kind of shots, full body shots, three-quarter body shots. So I'm kind of trying to mix and match like side views, back views, front views, different styles of clothing, different uh, positions of hands, different face, like smiling, not smiling, eyes closed, sitting in a car. So I'm kind of trying to vary a lot what each of the image is, and this is helping to get better model results. Uh, One thing that also helps a lot, well, I guess I didn't explain this, so let me explain while the training is going on. So why do I set things like that? So batch size of 4 and gradient accumulate steps of 10. That's because I don't want to calculate the gradient for every image every time we kind of look at the picture. I want to calculate the gradient once we have looked at all the pictures in the data set. So I always want to have this to match the total of image. So since I've got 40 image and I can do batches of 4 and I will have 10 repeats or 10 gradient accumulates, that totals up to 40. 4 times 10 equal 40. If I add, for example, 80 image and I had set like a train batch of 8, I would still do gradient accumulate steps of 10. If I had kept that to batches, to a train batch of 4, then I would put that as 20 to get 4 times 20 equal 40. Now, why do I set my train batch of 4? Why didn't I set it to 8 or 10? You would ask, so that I would use larger batch. Well, there's a problem with that, because the larger you make your train batch, each image within the training batch has to have the exact same aspect ratio and size. So that means that for tall image are going to start to get mixed now with square kind of aspect ratio image, and I'm going to have to start to crop a lot of those image either height wise or width wise, and then you start to lose like part of the head, part of the feet, and so on. So to minimize that cropping, then I try to set a group or a batch train number that is not too high. So if I had like 300, 600 image, then I could do batches of 8, right? Because across those 600 image, there's not going to be much cropping because I'm going to group them in batches of 8, but because there are so many image, it's unlikely that I'm going to start to match like a landscape aspect ratio with a portrait aspect ratio, because the software that kind of groups them will look at all image in the folder, and then it's going to sort them by aspect ratio, and then it's going to go and iterate through them like 4 at a time. So it's going to take the first 4 image, calculate the average aspect ratio for them, and it's going to crop each image to match the average aspect ratio to minimize again the cropping amount for the image. So that's how it does its trick. When it's actually cropping, it's kind of sorting all the image by aspect ratio, then it's taking like the first 4 image in the group, and then it's going to crop them all to the same size and resize them all to the same size at the same time. So that's what's happening behind the scene when we are actually grouping all of those image in 10 groups in this case. So it's kind of a smart cropping and grouping piece of software that is used. So where are we now with the training? Let's have a look. So we're halfway. So I'm going to pause the recording and I'm going to let that go through, and then we can start to look at the result for the model. Okay, so we're almost to the end. 5 seconds left. And we should be able to start to look at the result. Cool. So now we have the new model ready. So let's bring, I guess, the GUI so that we can start to look at it. So let me bring this here. So I've kind of prepared while this was running like the first prompt that we're going to try. So we're going to use again the Kylie Jenner model we just created. We're going to prompt using the trigger word Kylie Jenner, and we're going to say for full body portrait, wearing a white t-shirt and blue jeans, sharp bokeh, candid shot, realistic, and film grain. And as the negative prompt, I'm going to use the drawing and digital art to kind of, I don't want to get an image that looks fake, so I want to go for realistic, so I'm going to use that for that one. So let's generate the image and see the result. So already we can tell that we have the t-shirt, the jeans, which looks good, exactly what we were looking for. And now the high-res fixed face is going to bring even more details about the model, and that's going to give us a great idea of how far or how close we are from a likeness point of view to the data set that we used. And from what I can tell, I think we are pretty close to perfection. So let's have a look. So if we zoom in, yeah, I think we have a pretty good model on our hand. It looks really good. Details are very good. There's no fuzziness, no nothing. As you can see, using also the gradient accumulation will kind of get rid of some of the noisy or blurry image. It won't kind of break your model because of those. So it can take like fairly poor quality image and create still fairly good result when you use the large or the actual training batch size of more than one and the gradient accumulate to actually calculate the gradient descent across all of the image in the data set. So let's quickly try another one. Which one could we try? Kylie Jenner. We could say full body portrait, riding a motorcycle, wearing a black leather jacket, sharp, okay, candid shot. I guess now we're gonna go for an action shot. Action shot. Realistic film grain. Film grain helps kind of bring also a more realistic look to the results. I find that by doing film grain, it doesn't have this kind of flat, perfectly, like almost like too perfect kind of a look. So bringing in some film grain is going to help with the overall look of the actual image to make it more realistic. So I think we have the leather jacket. And as you can see, just using two words as the caption, so Kylie Jenner, make sure that those two words get all of the training associated to those. So because we always use them, you get all of what the model was able to extract from the data set about the subject to be associated to those two keywords. So the results I find are much better. The fewer words you use for a caption, the better the result will be. And again, super sharp, super nice results. So I think we have a pretty good model that we've trained, and you've seen it's super easy. It doesn't take much time. The actual image themselves are just what you're going to find using Google to look for Kylie Jenner. So I just kind of used the Bing search image and I went and kind of picked image in the group. That's how I kind of did all of my data set by finding 40 of those image, and that's it. Just vary the pauses, vary the like close up, full body shots, like 3/4 body shots, uh, colors, look, smiles, no smiles, different face expressions. Kind of go for a variety of those, as you can see here. So, and kind of try to stay in the same age space as well. Don't put old looking image with newer, like younger looking image, because you're going to kind of cause some potential issues in the learning. But in this case, those are pretty much all image that looks like her. So yeah, just go for that. Just pick the image. No need for a caption. Just put the actual captions you want in the actual folder name after the repeats number. So repeats underscore, then the caption words that you want to use. In this case, I used Kylie Jenner, and yeah, it works perfectly, super easy, super great. And make sure to use the latest version of the code so that you have access to the GUI. I don't know if I pushed it yet to the repo, but I'm going to push an update of the code so that you get access to this group image Python tool that is used to kind of group all of those images together so that you have access to the latest and greatest code, and use this technique to create your LoHA, and I guess enjoy the results and share with others on the Civit AI website. So hope you like the actual little YouTube training session, and yeah, enjoy. Bye guys.